All right, this is the last lesson for IM Algebra 2, Topic 2, Rational Functions. We're talking about the geometric sum formula, which is this formula given to us right here. A is your initial value or your starting amount, R is your rate, and N, I say the number of whatever because it could be years, number of doses if you're talking about medicine or caffeine or anything like that, so that's not really an exact thing that it is. Be very careful. This means question 1, question 2. They are not actually part of the sequence, but if they were, it would not actually make a difference in this case. So the approximate sum of the first 50 terms. So 50 is going to be our n. For the first one, our starting amount is 1/2. 1 minus, we'll talk about the rate here in a second. To get from 1/2 to 1/4 to 1/8 to 1/16, if you look, we're multiplying our denominator by 2, which is 1/2. So what we're doing is we're multiplying by 1/2. We're getting smaller, so it's a decrease. So it's going to be 0.5. Have that to the 50th, and then our 0.5 right here. The same thing, where when we look to get from 1 to 1/2, 1/2 to 1/4, you're multiplying by 1/2 again. It's still going to be 50 terms. The only difference is that your starting number is now 1. So they very well could be part of the same sequence, but it says they're 2 separate ones. So then we can go ahead and plug this into the calculator, and let's see what we get. Okay, so when we do the first one, we get 1. When we do the second one, we get 2. That does make sense because if you look, if we ignore this one right here, it's the exact same sequence, but then when we add this one in, it doubles that. Okay, so those are the approximate sums of the first 50 terms, meaning if you added up every single number for 50 times, that's what you would get. In 26.2, you're looking at selling houses. I'm trying to do it so you can see the words. Okay, close enough. Ignore the stain on my counter. In 2012, about 71,000 homes were sold in the UK. For the next 3 years, the number of homes sold increased by about 18% annually. Assuming the sales trend continues, how many homes were sold in 2013, 2014? Okay, so yeah, 71,000 is going to be our initial amount. So if we were to do our equation, 71,000, unfortunately, you do need to include all those zeros. 1 minus, now this 18%, because it's increasing by 18%, when we combine those, we're going to get 1.18. Because to increase, you have to have over 100%. You have that additional 18%. So we have 1 minus 1.18 and 1 minus 1.18. Now let's talk about our n. In 2012, no time has passed. 0, right? That's your starting. In 2013, only 1 year has passed. So this is our 2013. To find your 2014, it's going to be similar, but instead your exponent is going to be what? How many years have passed? 2. And this is where it gets kind of confusing, and that's something I have to think about. From 2012 to 2013 is 1 year. And the ranges get me. So the first couple won't. The next one, that's where it might get you. It might not. You might be like, I don't know what she's talking about. So let's look at what we get for those. You should be kind of used to evaluating these by now. I'll be right back. All right, I'm actually going to backtrack. And this is what I mean by it gets confusing. This is not going to give you the correct answer. First of all, you just using 71 as their initial value because they're measuring in thousands. Second of all, let's talk about this. It's going to erase. You are changing by 18%. You really can just multiply by this. Your initial times your change, so this will get you back up to the 71 plus the 18% more. This was when we were measuring in thousands, so this is the same as saying 83.78, I believe. So 83.8. Just put that decimal right there. Which is equivalent, because we're measuring in thousands, to 83,780. So then that same idea goes for here. There's 2 different ways you can do it. you can take your initial amount of 71,000 and multiply it by 1.18 to get 2013, and then by another 1.18 to get 2014. You could do 71 times 1.18 squared, right, because you have two of them, or you could take your most recent answer, the 83.78, and multiply that by the 1.18. Either way, you should get that it is about 98.9. And again, that's thousand, so that'd be 98,900. The reason we're not using this equation right here is because it's not really necessary. We're not adding up how many houses have been sold total. We're just talking about the individual year. And that's what threw me off when I originally started this. You are just talking about individual year, not a range of years. Okay. Now here is a range because they're using this equation. So we plugged in 11, which is our n, which means it's 11 years. So how many houses are sold between 2012 and now it's 11 years. So from 2012 to 2013 is 1 year. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is where I start getting confused because it is from 2012 to 2013. Oh, sorry, 2012 and 2023. I have to do it this way because whenever I think it makes sense, I mess up somewhere. So if you need to count it out like this, no one's going to judge you for that. Question 3, predict the total number of houses sold from 2012 to 2017. Okay, so you could predict. You just looked at between 2012 and 2023. You looked at how many are sold in 2014, or I'm okay if you go ahead and like plug in the numbers. So you have 71. We are going to use the equation now because we're talking about a year range. And I believe this is going to be 5 years. Let me double check that. Because we got 1, 2. Nope, it's 6. See, this is where I start going downhill. Because oh, I messed up on the other one too. See? It's 2022. This is 1 year, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Haha. This is why we triple check our work, and this is how you know teachers are human too. All right, anyway, 6 years because 2012 is a year, 13 is a year, 14, 15, 16, 17. I wrote down 6 numbers, which is why it's 6 when you plug it in. Okay, so when we do this, we should get approximately 670.4 thousand. Does it make sense that in only 6 years, they have sold over 670,000 houses in the UK? Maybe, but could it continue on? Probably not. It's pretty unreasonable to continue at this because if you look at this and you grew another year, like if you plugged in 7, that would be, well, let's do it. If you plug in 7 instead, let's see what we get. Let's see how much difference there is in 1 more year. Okay, so if you plugged in 7, it would jump from 670 to 862, which is really close to another 200,000 homes. While the UK might be populated, I don't think it's that populated, and it seems pretty unreasonable for the trend to continue. So, no, that is not going to happen. Maybe there was a housing boom during those first 3 years, but it is not going to continue at that rate. So when we look at 26.3, we're talking about an interest rate, and it's 5%. So this is going to be 1.05 because the interest gets you up to 100, 5% more. Be very careful. It's not 1.5. Also, just a note, 5% is a really good interest rate. Interest is good when you are saving money because it's kind of passive income where you're just making that extra money by not touching anything. But It is not good when you take out a loan and there's interest, or your credit card has interest on it, because you're going to owe that extra money instead. So predict how much you need to put into the account at the start of each year to have over 100,000 in it when you turn 70. So at the time of this video, I'm 29. I'm going to use that as an example. Most of you are anywhere from 14 to 19. So you figure out how many years it's going to take you to turn 70. Most of my students are between 52 to 54, but again, that's going to depend. So you want it to be 100,000. Oh, forgot a zero there. That looks awful, but we're going to go with it. You know that your initial amount is what you're trying to find. You're going to have 1 minus 1.05. 1 minus 1.05. For me, it's going to be 41 because it's 41 years until I turn. You can guess and check this original amount. Just figure out how much you would need to input every year. Yours is going to have more, so you have more years to accumulate. So you would need less of an initial amount than I do. Calculate how much the account would have after the deposit at the start of the 50th year. Yeah, we can do this. When I did it with my class, something else you could do, like an extension, is how much would you have at age 70? Or how would you have when you're 70? So you could use the same kind of equation you set up here and then just replace the beginning with your amount. So here we have 100. It's just going to be 50. So if you're 14 right now, it'll be when you're 64. If you're 18, it'll be when you're 68. I'm going to have 1 minus 1.05 to the 50th. If you do this extension, it might be a little different than your peers. It would definitely be different than mine. I'm going to get all of these set up and then give you time to calculate it. This is really good practice, inputting it into the calculator. It's the exact same every time except for your initial value. And then double check when you're writing this, especially when it's in the calculator, that you are maintaining 1.05 and you're not accidentally losing this zero. Okay, go ahead and calculate those. Okay, so if you only input $100 every year with a 5% interest rate, you would end up with $20,935. Okay. If you consider the fact that you're only depositing 100 for 50 years, that's 5,000. So that extra 15, 16,000 is just from that extra accumulation every single time. Here, if you input 500 for 50 years, it's what, 25,000, and you're making 104. I don't know if that was actually right. Pull that number out. And you can see, obviously, the more you put in, the more you're going to get out. And it's not just, well, it's pretty close to doubling. It is doubling. So if you were rounding, make sure you only round to 2 decimal points because 2 is cents. Okay. Say you decide to invest 1,000 into your account. And you're going to have the same interest rate, so that 1.05. How many years until it reaches 100,000? You can guess and check. That's 100% okay. There's also an official way to solve it if you want to do it that way. You haven't quite learned how to do it, but you could similarly to cross multiplication. Divide both sides by your 1,000, then multiply by your denominator, etc. If you think you're ready for that, you definitely could do that. That's something we're going to learn more in like topic, it's right after my semester switches. Exponential functions, whichever topic that is. So how many years? Well, at 1,000, 50 years, we have 209,000. So we know it's not going to take 50. When I did my 41 up here, and actually I did 41 for my 1,000 too, that gets me a little over 100,000. So you know it's still going to be under 41. And I can show you what I mean. So if I look at when I turned 70 and I have my 41 here, let's see how much that leaves me with. Okay, so when I plugged in 41, again, this is if I deposit $1,000 every year until I'm 70, it's $127,839. So it obviously needs to be less than 41. And we know it needs to be less than 50 because that gives us 209,000. So again, you can guess and check. I had some students who went down to like 30, 35 and tried that. When you do it, it should actually be 37. Now here's the trickier part. You need to make sure you're rounding up, because if you plug in 36, you're just going to be like a little bit under that 100,000. It would be in between the 36th and 37th year that you would reach the 100,000, and you want to go with when you have 100,000. So if you evaluate both of those, you can kind of see what I'm talking about. So in my 36th year saving, I would only have 95,836, and then if I want to include my cents, and 32 cents. When I have 37 years, I am over that 100,000, so it should be 37. Let's do some practice problems. I started the video just so you could hear my toddler procrastinating on her way to bed. All right, so Kieran plans to save $200 per year, and we're looking at Bank A and Bank B. So we have Bank A and Bank B. Okay, 200 for both of them. Bank A has 6% interest. And we're trying to figure out the number of years. Bank B has 4% interest. And this compounded annually means you're only getting that money like at the end of the year. There are places that are continuously compounded, meaning like each day you're going to compound interest. You want $10,000. Okay, so you want this to be 10,000. Oh, she's no longer happy. And this to be 10,000. So again, you can guess and check. You can properly solve, but I'll give you a minute to do that, and then I'll come back with the answers. Okay, so you should get Bank A is 24 years, Bank B is 26. That does make sense because you have a higher interest rate, so it's going to take less time. You can double check that by plugging in 24 for N and 26 for N. You should get a number that's over 10,000. For question 2, the first 20 terms in each sequence, you need to look at what you're doing each time, so how you're changing. You're multiplying by 2/3. Normally, I prefer decimals when you're doing this equation, but because 2/3 is such a nasty decimal and it's not going to be exact, you can do that 2/3. Just make sure you have parentheses when you put the 20 up here, because it has to be 2 to the 20th over 3 to the 20th. That is not going to be the same as 2 to the 20th over just 3. Okay, so that's the difference of using your parentheses the correct way versus not using your parentheses the incorrect way. And then again, 1 minus 2 over 3. I'm going to go ahead and set all of these up with you so then you can go back and evaluate. Here, 3, 6 over 3, 12 over 9. This is like 3 over 1. And that should kind of help you see that you're doubling your numerator and tripling your denominator. So what's really happening is you're multiplying by 2/3 again. So it's going to be almost the exact same equation except with a 3 in front. Again, make sure you're going to keep your parentheses. Here, to get from 4 to 2 to 1, you are dividing by 2. Another way to think of that is that you're multiplying by 1/2. So dividing by 2 is the same as multiplying by 1/2. Your starting number is 4. 1 minus 0.5, that's nice, to the 20th. 1 minus 0.5. These two, very similar, it's just your starting number, so this should be triple that, but go ahead and evaluate these now. Okay, you should get approximately 3. That's why it's a squiggly equals, because it's not exactly 3. This is 9. Again, that is triple, so that makes sense. And then this is 8. Question 3, Diego wonders how much money he could save over 25 years if he puts $150 a year into an account with 4% interest rate compounded annually. He calculates the following, thinks he does something wrong because he ends up with a very small amount of money. When we look at this, because it's interest, it should be a number greater than 1. So it should be this 1.04. And then this is actually going to be negative 0.04. Because if I rewrite this, 1 minus 1.04 to the 25th. 1 minus 1.04, that's where I'm getting that negative 0.04 from. So when you calculate this, you should get 6,246 and 89 cents. So 6,246 and 89 cents. And that's just from plugging it in. So how many years? 25 years, 150 every year. He's going to end up with about 62.50, give or take. And that's it. That is the end of this topic.